Hey everyone, go ahead and grab your book, open it up to page 128. We're in lesson 9.2, covering slope and rate of change. So our learning target today is we're going to calculate and interpret the rate of change for a function, and we're going to understand the connection between rate of change and slope. So the rate of change for a function is the ratio of change in y, which is the dependent variable, to the change in x, which is the independent variable. So question 1, Margot went to the lumberyard to buy supplies to build the wheelchair ramp from the previous lesson with her grandparents. And she knows that she will need several pieces of wood to build the ramp, and each piece of wood costs $3. So let's write a function, f of x, for the total cost of wood pieces if Margot buys x pieces of wood. So our function is going to start with f of x equals, how much does one piece of wood cost? I boxed it in above, 3, and we don't know how many pieces of wood, so we're going to use the variable x. Okay? So question B, it says make an input-output table of ordered pairs, and then we're going to graph the function. So in our table, we are going to fill in the left side of the column, which is pieces of wood x. So we're going to do 0, 1, 2, 3, 4, and 5. And to figure out the total cost, okay, we would plug it in. So let's think about this. Here's our function. I'm just rewriting it from the question above. If she buys 0 pieces of wood, we could take that 0, or any number of wood, and we could plug it in right here for x, substitution. Okay? 3 times 0, 0 pieces of wood is going to cost $0. 3 times 1, $3. 3 times 2, 6. 3 times 3, 3 times 4, and 3 times 5. Okay? So now we are going to use this table, and these are like our ordered pairs, and we are going to graph these. So the first column is our x values, and the second column is our y values. So we're going to graph these as ordered pairs. Okay? So my first ordered pair is 0, 0. The second one is 1, 3, so I'm going to go halfway between 0 and 2, and up to 3. 2, 6, 3, 9, 4, 12, and 5, 15. Okay. Then, actually what I'm going to do is I am going to take a line and I'm going to connect this and notice that my line has an arrow at the end of it. Okay, that means that my function or my graph keeps going. What if she needs 100 pieces of wood in order to build this ramp? Okay, so make sure after you connect these that you draw an arrow at the end of your line. That shows that your function keeps going. All right? Question C, what is the slope of the line that you graphed? Well, remember, from lesson 9.1, we can count rise over run. So if I pick this point right here and this point, I'm going to count. I'm going up 3 and up 6. And I'm going over 1 space, but that's over 2 numbers. So we're going to see that. I'm going up from 0 to 6 and over from 0 to 2. 6 over 2, it reduces to 3. So our slope here is 3. All right, question D. By how much does the cost increase for each additional piece of wood purchased? Well, let's look at our table for this one. Okay, if I'm looking here, I'm adding one piece of wood. Here, my cost is going up by $3 every time. So question D, my answer is we're increasing by $3. Go ahead and turn your page to 129. Look at questions C and D. Our answer is 3 for both of these. So question E, how does the slope of the line relate to this situation with the pieces of the wood? Well, the slope of the line is the same as cost of one piece of wood. The slope of the line is the same as the cost of one piece of wood. So my slope is 3. It costs me $3 for every one piece of wood that we're buying in order to build the ramp. Question F. Is there a relationship between the slope of the line and the equation of the line? And if so, describe the relationship. Well, the equation of the line, if you remember, was this. F of x equals 3x. The slope is 3. So yes, I see a relationship. The slope is the coefficient of x in the equation or in the function. Coefficient is just a number in front of x. So see how 3 is right in front of x? That's the coefficient. All right, next question. Margot is going to work with a local carpenter during the summer. If she has to buy wood, she needs money in order to buy it. Okay, so each week she is going to earn $10 just for showing up, plus $2 per hour. $2 per hour. So write a function f of x for Margot's total earnings if she works x hours in 1 week. So I'm going to start with f of x equals, what does she make per hour? Per hour. $2. Do we know how many hours she's going to work? We don't. So we're going to use an x because they told us to. Plus, what else does she make once that week? Or an upfront payment is $10. Okay, this is the most common way to write it. It's like y equals mx plus b. This is like the proper form. If you wanted to, you could switch it and you could write 10 plus 2x to make sure that the x is with the 2. Because it's $2 per hour. That's our slope or our rate of change. And that 10 is our starting point or like the initial payment, the one-time amount that she earns. Okay, question B. Again, we're going to make an input-output table of ordered pairs, and then we're going to graph it. Okay, so let's fill in our hours here. We're going to go 0 on up. And if you don't know how to fill in this table, again, you can take our function, f of x equals 2x plus 10, and we can take our hours, which is our x values here, and we can substitute or plug them in for x. So it would be 2 times 0 plus 10, 2 times 1 plus 10. Okay, so if she works 0 hours, 0 plus 10 is $10. Okay, so it would look like this. 2 times 1 plus 10. 2 times 2 plus 10. And so on. Okay. But if she's earning $2 per hour, we're just going to go up by $2 every time, right? 2 plus 10 is 12. Okay, so we're adding 2 every time because she's earning $2 per hour. Let's go ahead and graph this. My starting point is 0, 10. That's my y-intercept. So think about this as an ordered pair. 0, 10. 0, 10 is right here. Okay. Now, on my y or on my x-axis, sorry, they don't label. Here's a 1. Here's a 3. Sometimes they don't write them all in. So I'm going to go over to 1, up 12, over 2, up to 14, 3, 16, 4, 18, 5, 20, and 6, 22 is not on my graph. All right, take a straight edge, and I want you to connect these, and I want you to use an arrow at the end of your line to show that it continues, show that the pattern keeps going. And then when you're ready, jump to page 130, and I'm going to skip question C, and we're going to go straight to D. Does the function have a constant rate of change? If so, what is it? Okay, in order to figure out a constant rate of change, let's look at our table here. And let's look at our hours. Are our hours increasing by the same thing every time? Adding 1, adding 1. Yep. Perfect. All right, adding 2, 2, going up by 2. So is that constant? My y values are changing by 2. My x values are changing by 1. If I simplify, we get 2. So yes, this is a constant rate of change, and it's 2. Got it? All right, question E. What is the slope of the line that you graphed? So let's look at the graph, and remember, when we look at our graph, we are going to count rise over run. Okay, so I could use this point to that point, or this point to that point. It really does not matter because the slope between any 2 points is always the same. Okay, so if I'm looking here, I'm going from 10 up to 12. Now that looks like I'm moving 1 space, 1 tick mark, but how many numbers is that? It's 2 numbers. So from 10 up to 12. So my rise from 10 to 12 is 2. And then let's go ahead and count the run. My run, I'm going from 0 over to 1. Okay, so from 0 to 1, we're just jumping over, or we're moving one number. Now remember, we can always reduce. Okay, we're going to reduce to 2. And if you want, I can write out the math for you. So I use the point 0, 10, and I use the point 1, 12. So from 12 to 10, we move 2 numbers. And from 1 to 0, we moved 1 number. So my answer was 2. Okay? Describe the meaning of the slope within the context of Margot's job. Well, my slope is 2, my rate of change is 2. Why would it be 2? Well, think. That represents how much money Margot earns each hour, per hour. So my slope is 2, my rate of change is 2, because that's her earnings per hour or each hour. Good? All right, question G. Describe the relationship between the slope of the line, the rate of change, and the equation of the line. Describe the relationship between the slope of the line, the rate of change, and the equation of the line. Okay, I'm going to type this in. The slope is the same as the rate of change, right? Those are equal. They were both 2. And the slope is the coefficient of the x in the equation. So slope and rate of change are synonymous. They mean the same exact thing. They were all 2. And then f of x equals 2x. That's the number in front of the x. So essentially, they're all the same thing. Question H. How much will Margot earn if she works for 8 hours in 1 week? Well, if I scroll back up to our table or our graph, 8 was not on there. Okay, we stopped at 6. But we have a function here. So we're going to use this function right here. And we can take any number that we want and we can plug in the number of hours for x to figure out how much money we're going to earn. Honestly, I do this a lot. Okay, for the first time this summer, I worked at Hankered Hills, and so I would figure out how much money I was going to make depending on how many hours I worked. So a lot of people do this. So we're going to take our function, f of x equals 2x plus 10, and x here stands for hours, and we have 8 hours. So I'm going to erase my x, And I'm actually going to replace it, or I'm going to substitute in the 8. So go ahead and figure that out. What's 2 times 8 plus 10? Our answer, she gets $26. All right, one more situation. Question 3. By the end of the summer, Margot has saved a total of $375. Recall that each of the small pieces of wood costs $3 each. So $375. Each piece of wood is $3 each. We are going to write a function f of x for the amount of money that Margot still has if she buys x pieces of wood. So here x stands for wood. So every function starts with f of x. That's back from activity 5 in first trimester. And our total amount of money that she has is $375 minus 3x. Why is it minus 3x or subtract 3x or negative 3x? Because she's buying pieces of wood, right? She's losing money. Now, if we were to rearrange this to look like slope-intercept form, we could write it as negative 3x plus 375. I'm running out of room. Slide this. 375. So either way, those mean the same thing. My 375s are positive because that's how much money she has. And we have a negative 3x because we're losing $3 for one piece of wood. All right, question B. We're going to make an input-output table. And then again, we're going to graph it. Now, looking at my graph, I'm going to go up by, looks like we're going up by 25s here. How did I know that? Because this right here is 0, nothing, and then 50. So halfway between 0 and 50 is 25. So let's go up by 25s. 0, 25, 50, 75, 100, and then 125. Right, before we went up by ones, but in all reality, she needs a lot more money or a lot more pieces of wood than just 1, 2, 3, 4, 5. Okay, so how do we figure this out? Well, obviously, if she buys 0 pieces of wood, the remaining amount of money that she has is $375. But you can figure out the rest by using your calculator. Okay, so you can type in negative 3 times 25, that's our x value. Okay, see how this says x? Well, we're plugging in 25 for x plus that 375. So here was my function. Okay, so we're taking out the x. It's coming out of the game and it's sitting on the bench. And what we're plugging in is our x values. So we're doing substitution here. Okay, so go ahead and take the time to pause, and I would like you to plug in all of these numbers to fill in the table. You can do it. Make sure you have a negative 3 times 25 plus 375. Go for it. Okay, hopefully your table looks like mine. 300, 225, 150, 75, and 0. So if she buys 125 pieces of wood, she spent all of her money, she has 0 remaining. So let's go over on our graph, and we're going to graph these. 0, 375, that's my starting point or my y-intercept. I'm up here in between 350 and 400. 25, 300. 50, 225. 75, 150. 100, 75. 125, and 0. Go ahead and connect these with a straight line. We do not need arrows. Because we can't have negative amounts of money or negative amounts of pieces of wood. So we're just going to connect them with a straight line. And again, we're going to skip question C and we're going to jump to question D. Does the function have a constant rate of change? And if so, what is it? So I'm going to erase these numbers here. And let's look at our table. What are we going up by on our x values every time? Pieces of wood here. We're going up by 25. 25. Okay, that's consistent. Perfect. And what are we doing in our money column? The second column, the y column. We're going down by 75, down by 75, down by 75. Okay, so it looks consistent to me. Yes. We are going down by 75 every time with our money, and we're going up by 25 pieces of wood. So let's divide that out. What do we get? -3. So yes, our rate of change is constant, and it's a -3. Question E, what is the slope of the line that you graphed? All right, let's look at this. From here to here, or here to here, I'm going down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Okay, but we should probably use the ordered pairs. And we should look at each box. It actually isn't worth just 1. It's worth 25. Okay? So if we use 2 points, we could use 0 and 375. And the next one we could use is 25 and 300. So we're going to subtract our y values, right? We were at 375 minus 300. Go ahead and subtract those two things. And we get 75. 0 minus 25. So either way, we get a -3. And how do I know that this slope is negative? So if I go back up and look, this line is decreasing. It's going down. So I know my slope is negative. Okay, so I'm going down 1, 2, 3 boxes over 1. So my slope is -3 over 1, which simplifies to -3. And I know that I can count the boxes for this graph because my y-axis, each tick mark is 25. And on my x-axis, each tick mark is also 25. So it works to count the boxes here. So I'm going down 25, 50, 75. So down 75, over 25, and that reduces to a -3. So question F, how are the rate of change of the function and the slope related? Well, we got a -3 both times, so they are equal or they are the same. Question G, describe the meaning of the slope within the context of Margot's savings. Well, the slope tells how much Margot's savings changes for each piece of wood purchased. Right, our slope is -3. That makes sense because each wood costs $3. How does this slope differ from the other slopes that we've seen in this activity? This slope is negative. And how do we know that? Because our line was decreasing. Our line is declining. Why? Because she's losing money. Question 4. The constant rate of change of a function is -5. Describe the graph of a function as you look at it from left to right. Go ahead and answer that question on your own. So that means your graph goes down 5 units and over 1 unit. Or it's declining, it's decreasing. It's going down 5 over 1, down 5 over 1. Question 5, does this table represent data with a constant rate of change? Justify your answer. So we have to figure out the slope or the rate of change between all of these points. Okay, so let's look at these 2 points first. Okay, so my change in y values go on top, and it's my second y minus the first y. So 5 minus -5. What do we get? From -5 to 5, how many numbers do we move? 10. Perfect. 4 minus 2. From 2 to 4, how many numbers do we move? Good. And let's reduce that. 10 divided by 2. Perfect. All right. How many numbers do we jump from 5 up to 20? Good. 15. How many do we go from 4 up to 7? 3. Let's reduce that. 15 divided by 3, we get 5. So far, are they the same? Yep, but we have to keep going. Okay, if they were different, we could stop right now. But we have to keep going and see if they're the same from here to here and there to there. So from 20 to 40, how many numbers do we jump or move? 20. And from 7 to 11, 4. And what's 20 divided by 4? We get 5. So is that a constant rate of change? Yes.